I did the sketch with you, all right? I did that yesterday, okay. So anyways, this is the scenario here. It's very important to note that the helicopter is somewhere in between, because if I had indicated that the helicopter is not in between, right, then you would have had a vastly different experience, right? You would have had, I'm just gonna let you know, right, if the helicopter is here and it sees the ambulance and the crash site, then you have something like this happening here, right? So you would have one angle of depression is here, and the other angle of depression would get you to here. Terrible graph, right? But that's one, and this is another one. So that's a different scenario, okay, when that happens, so you have to watch out for that. So if it doesn't say in between, we're assuming that it's out there somewhere. If it does say it's somewhere in between the two things, then you know it doesn't matter exactly where, just make sure it's in between, all right? Because it does make the question completely different. All right, so because of the height, because of this height here, which is right in the center or somewhere inside the triangle, we have to work with right triangles, okay? That's almost a given. So which one should we work with first? Because ultimately, we want to know how far the ambulance is from the collision site. And so, morning. Let me think as a student, perhaps. Maybe some of you said, well, if I have this angle and that angle, I can take that away from 180 to get this, right? And then I'll be able to just figure out the side across from it. But the problem is, you want all of this, and you have this whole angle. You don't have another pair. The only pair that exists is 27 and 400. Are you looking up, right? 27 and 400. That is a pair, but that's not the entire triangle, right? That is just the right triangle, this pair. So sometimes students pair things up, and they're actually from two different triangles. Those pairs are not even in the same triangle, so you got to be very careful not to make that mistake, okay? So I will, it doesn't matter how you start. I'm going to start with this one here, and then I'll work with this one. And so my goal is to find x and y separately and then add them up. Are there different ways of doing this? Perhaps, yes, most likely. But this is how I approach it. So for triangle 1, right, triangle number 1, I will solve for x. And here we go. So we go sine of 27, and remember the 27 came down here, and I used the alternate interior angles are congruent property, right? That's how I came up with the 27, which is quite convenient for me. And I just put the 400 meters there, and in order to find this x, I need to have just this angle here, okay? So you could find that by just going 180 minus 90 minus 27, and that gives you 63 up here. So maybe it's worth sketching this. Maybe you need to do this so we know this is 400, this is 27, this is 63 up here. Okay, I found this by using sum of triangle to get the 63, and so this is gonna get me this x here. This is paired up with x. The 63 gets me this stretch here. Okay, so sine of 63 over x, and I solve for x there, so it's 400 times sine of 63 divided by sine of 27. So x is equal to, I'm just going to give you the answer, 785. And here's a little nuance here. Watch this. Why would I do 4 decimals? Sorry, 0442. There's one too many 4s there. Why would I do 4 decimals? It's not, right now, I don't want you to erase or redo anything because this is not our final answer yet. So you either use all decimals or use 4 in the meantime. Because I'm going to add this to y to get my final answer. I really want AC. That's what I want. Okay. I don't think you want AC today, but maybe tomorrow. There we go. So triangle number 2, this one here, solve for y. Okay. Again, I'll maybe make that little triangle here. So angles are really easy and quick to come up with, right? So if this is 62, we just subtract that and we get 28 up here. Okay, that's 28 degrees up there, sum of triangle. So that will allow me to find the y. And remember, this is 400 still, so this is the pair I need. So I'm going to go sine of 62 over 400. Sine of 28 gets me y. Okay. Y is equal to 400 times that, divided by sine 62, that's 212.6838 meters. So this is important, and this is important. Obviously, that would get you marks, right? And so AC is going to be x plus y, which is going to be 785.04 dot 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 plus 212.68 and so forth. And when you add those up, you get 997.73 meters. So this is the ultimate final answer here. That is our total distance from here to here. Okay. How else could you have done this? I'm just thinking here. You could have probably use this pair here, sine, and then use the 90 to get to the hypotenuse, this one here, the slant, the diagonal. And then you can actually pair this side up with 62, right, all across, and then get this big angle up here to find the total distance across here. Yes, it can be done. And I will probably do that as I go along. I'll show you different ways of solving, because right, the more options you have, the better you're going to understand this unit, right? The key is to not mix up triangles. That's the key here, okay? Let's do some converting here, or this actually goes back to chapter 8. This one here is actually review of chapter 8. I just threw it in there. The province on the provincial exam in grade 12 will do that at least once. They'll mix 2 units up in one question. And it shouldn't surprise you. It won't even be that big of a deal, but you just need to be aware of that. So if the ambulance is traveling at 30 kilometers an hour due to rush hour traffic, how long in minutes will it take for the ambulance to get to the site of the crash? Okay. A couple of things, what you could do is keep the speed as is, turn this into kilometers, okay? So 997.73 meters. I know that 1 kilometer has 1,000 meters, and some of you would just instinctively divide this by 1,000, I know that. So that's 0.99773, like that, kilometers. So it's not quite a kilometer, almost. Very close, okay? So then you can set, so now you have a rate here. If it's 30 kilometers in 1 hour, right? That can be translated to, if this is probably better to just go 30 kilometers in 60 minutes. I would rewrite that in minutes. Maybe that's faster because you want your time in minutes, okay? Then you just say, well, if this is true, 30 kilometers in 60 minutes, then how many minutes will it take to travel this many kilometers, right? This is my x in minutes. So I don't have an equal sign. I just say, hey, I'm going to rewrite this as a rate in minutes. This is not a unit rate. Do you remember unit rates? This is a unit rate, something per 1. This is no longer a unit rate, but it's still a rate, okay? Just so you know. and you just cross multiply and divide just like before. That's 60 minutes divided by 30 kilometers. By the way, this is kilometers as well, so kilometers cancel out, you're left with minutes. So if you multiply and divide, according to my key, you get 1.995, that keeps going. So that's effectively 2 minutes, right? It'll take the ambulance 2 minutes to get to the crash site. A little bit of chapter 8 review here. You could have turned another option would have been to turn your speed to meters, right? Meters per minute. You could have done that and then just kept your distance in meters. Same thing. You're going to get the same answer. Okay? All right. I'm going to pause here. You got these pages, right? Up on the screen, 53, 55. But I'll post everything from 49 to 60.